Okay. Good morning. My name is Yat Lee, and my topic is privacy-aware multimodal AI for early health deteriorations warning in the remote patient monitoring. So the aim of my report is to design an AI-based framework that can transform continuous remote patient data into a timely and personalized deteriorations warnings while also considering patient privacy. So the remote patient monitoring, or we say the RPM, which is the use of the wearable sensors, mobile devices, and the digital health platforms to collect patient data outside of the traditional clinical settings. And this has become increasingly important because the growth of aging populations, chronic disease management, and also for the demand of the home-based healthcare. However, many current RPM systems are still focused on collecting or displaying data rather than interpreting it into clinical meaningful warning signals. Therefore, A- existing AI-enabled systems also face issues such as limited transparencies, narrow clinical functionalities, and also potential privacy risk. Therefore, I have identified the central problem is how to transfer those noisy and heterogeneous and the privacy-sensitive RBM data into a useful early warning output. So in my framework, each patient has multiple data sources, including vital signs, activities, and the sleeping patterns. Patient reports we also will consider text-based patient report and for those clinical contents. My model will aims to produce a personalized risk score between 0 to 1, representing the probability of the deteriorations in the future window, such as next 12 hours. And this is challenging because RPM data are heterogeneous deterioration patterns also being really personalized. Therefore, it potentially can cause false alarms and to lead to alarm fatigue for the healthcare professionals. And also, the healthcare data are highly sensitive. Therefore, for my proposed framework, the is demonstrated by these figures. The fig, the first layer of collect the first layer of the collection data collections will collect three types of data: variable vital signs, contentless mmWave radar signals, and the patient-reported text. And the second layers will use the modalities specific encoders, for example, as I shown, LSTM or transformer models, which can provide time series vital signs and the signal encoder. And also we also provide the signal encoders, which can to process radar signals and the BRTs that can encode symptom text, for example, the text-based report. And the third layers will use attention-based multimodal fusions to combine these representations. And finally, the model will output a personalized deterioration risk scores. And at the bottom, the training designs will be using the federal learnings and the segregation and the secure aggregations for reducing unnecessary centralizations of raw data patients. The key method is using attentional-based multimodal fusions. Different patients may have shown different deteriorations in different ways. For example, for one patient's oxygen saturations could be the most important signals. However, for another, repeated report of fatigue or heart rates may be more informative. Attention allows the models to assign dynamic weights to different modalities according to their relevance, which makes the framework more flexible in compared to the fixed rule base or the single modality systems. And the second key method is the privacy-aware federal trainings. Instead of uploading raw patient data to a central server, the local modules will be trained on the patient sides or institution sides, and only the updates of the model are shared. Then, and by implementation of the secure aggregations can further reduce the exposures of the individual updates. And the limitations of my framework is the framework is not yet been validated on the real world clinical data sets. It's also assumed that useful signals are available for all modalities, which is potentially not always possible for home monitorings. And the federal trainings also faces a challenges, which is those non IDD data that for processing non-IDD data because patients potentially have different baselines and their health conditions. And the future works, I think, should be therefore focused on real-world RPM database evaluations or prospective clinical studies. Also focus on the personalized federal training learnings for the fairness and the usability of testings before any clinical deployments. Therefore, include in conclusions, this framework will provide a conceptual design for combining multi-modules AI and privacy-aware trainings for supporting early healthcare deteriorations warning in remote patient monitoring. And thank you so much for listening. And this is my end of my slides.